All right, so far we've been working with position time graphs, and in this lesson we're going to introduce velocity time graphs. You're going to be able to explain how they represent both the direction and the speed of motion in one dimension, and you're also going to be able to interpret them. So first, let's start by remembering that velocity is a vector, and that means that it has both magnitude, which in the case of velocity we call the speed, and direction. And so we need a way of representing both of those in a velocity time graph, both how fast it's going, the speed, and in what direction. Also remember that we've used sign conventions, so plus or minus, to represent the direction if we're only working in one dimension. In other words, if we're moving backwards and forwards along one line. So for example, if we call right the positive direction, then left is the negative direction. If we call east the positive direction, then west is the negative direction, etc. So once we've set this up, the plus and the minus tell us the direction. Once we've got that, we can think of a special kind of speedometer. Usually a speedometer has a 0 at the bottom left, and then as you go clockwise, the numbers get higher to show you moving at faster speeds. But we can incorporate direction by putting the 0 in the middle. So now if the 0 is in the middle, then if the needle were pointing just like that, that would indicate motion in the positive direction, or positive velocity. And that might be relatively slow positive velocity. Whereas something like this, where the number read out would be higher, would be a faster positive velocity. If the needle were right at the middle, at the 0, then that object would have 0 velocity. It would be stationary, not moving. And if it were to the left of the 0, then we could have either a slow, or if it were further out, a fast velocity in the negative direction. For example, to the left, if right were the positive direction. With position time graphs, we saw that the y values were always the position, either in the positive or the negative direction from the origin. What a velocity time graph is going to do is it's going to graph the number on the speedometer, either a small or a big positive number, or a small or a big negative number, against the time's on the x-axis, to show us how fast and in what direction the object is moving. Let's take a look at an example. This is the same simulation from PhET that we used in an earlier lesson, and I'll put the link once again in an annotation. So first, let's just watch the situation. This person starts at 2 meters to the left of the origin. They move to the right with constant velocity, and then at the 6 meter mark, turn around and move much more slowly, but again with constant velocity, now to the left in the negative direction, and then they stop a little bit to the right of the 2 meter mark. Let's watch that again now with the position time graph underneath. Remember that the y value indicated by the arrow here in a position time graph gives us the position in either the positive or the negative direction relative to the origin. Because the person is starting in the negative direction to the left of the origin, the arrow and the y value do too. Let's watch what happens. As they move to the right with constant velocity, we see a constant positive slope. When they get to the 6 meter mark and turn around, now they're moving in the negative direction, again with constant velocity, so we see a constant negative slope. And then at this point, they're stationary, and so we see a slope of 0 because the position isn't changing. Let's do it again, and let's think about what the speedometer, if this person were carrying one, would be showing. So first it would show a positive velocity, then it would show a negative velocity of a lesser magnitude, and then at the end, it would show a velocity of 0 once the person comes to rest. As we said, the velocity time graph is going to graph the value that the needle on the speedometer is pointing to against the time. So let's watch it again now and graph those values below. This is a velocity time graph where instead of position on the y-axis, we have velocity. We have a constant positive velocity, then quickly we turn around and have a negative constant velocity of a lesser magnitude, and then at the end, we have a velocity of 0 when the person comes to a stop. One last time with the two graphs together, position above and velocity below. First constant positive velocity, then constant negative velocity, and then at the end, we get 0 velocity. Notice the connection between the slope of the top graph, which is the velocity, and the y value of the bottom graph, which is also velocity. That's where we're going next with this. To sum up then, velocity time graphs have velocity on the vertical or the y-axis and time on the horizontal or the x-axis. And remember that what you're plotting as the y values are the speedometer readings. So a speedometer reading of 0 would be a dot on the time axis. A slower speed would be a smaller y value, and a faster speed in the positive direction, here defined as right, would look like that. Similarly, as you move away from the time axis in the negative direction, you're picking up speed. But here, if right is positive, any point above the time axis means that you're moving right. And any point below the time axis indicates that the object is moving left. For example, this could be an object that's moving to the right and getting faster, and now it's getting slower because the numbers are getting lower, but it's still moving to the right. Still moving to the right, still moving to the right. Now it's not moving at all, and here it's moving to the left and moving to the left and picking up speed. Now it's still moving to the left, but moving slower because we're getting lesser values on the speedometer. Okay, so that's an introduction to velocity time graphs.